Assalamualaikum warahmatullahi wabarakatuh, and hi, welcome to our group presentation, which is group number 2D. And today we will be presenting about the experiment of deflection of curve bar and Davits. Without further ado, let's go to the introduction. Okay, before I start, my name is Muhammad Hasanuddin bin Fazil, and my metric number is DD180061. So today I will talk about the introduction of this experiment. So Davits and curve bars is actually a simple and common structure that we can find in the industry. Usually these bars or specimen will be used to suspend a lifeboat on a ship. Another example that we can find is these bars will actually be used in railway tracks, which is to suspend the electrical cable along the railway tracks. But there is a limitation design, which is the deflection that can caused by the load that they will suspend. So that's why we need to know the deflection for this specimen. We will be move on to theory of this experiment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman Hakim bin Ali, CD107103. Okay, today I would like to present about theory in deflection of curve bar and Davits. Okay, first, energy method is a method of determine the stress and deformation in structure subject to both static and impact loading. As a load is applied, structure note the horizontal and vertical deflection. The theoretical deflection of curve shape are most easily found by applying strain energy. This is investigating the structure behavior with theoretical prediction can be made. In this experiment, you can compare theoretical prediction and experiment result.
I have something to add to the theory. Actually, there are 4 different types of bars, which is semicircle, quarter circle, curve Davits, and angle Davits, and all of them has a different formula, which is this one for semicircle, which is the vertical and horizontal deflection, and this one for the quarter circle, the formula of horizontal and vertical deflection, and this one which is the formula for curve Davits, and this one which is the formula of angle Davits. So basically there are different formulas, so that's why we need to know the deflection for each of them.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Muhammad Noor. My metric card number is DD170075. So I will continue about the result for this experiment. As we can see here, there are 4 types of structure or specimen, which is semicircle, quarter circle, curve Davits, and angle Davits. And this structure will have been applied to some amount of load to see the deflection occur to the structure. The mass value that been applied is between 0 to 500 with increment 100 gram till it reaches 500 gram. As we can see here, this is delta V, means the deflection, vertical deflection, while delta H is the horizontal deflection. These all are the experimental value of deflection in each specimen. Means the value is being recorded by conducting the experiment. So next, after we get the result, we can calculate the second moment of area using the formula. As you can see, the formula is BD power of 3 divided by 12. B is the breadth of section, while the D is the depth of section. After that, we can calculate the I value for the second moment of area for each specimen. Here are the value of the second moment of area for each specimen.
Assalamualaikum and stay safe. Okay, my name is Muhammad Shafiq Aiman bin Amanuddin, matrix number DD180066. Now, I would like to present about the observation of this experiment, which is the deflection of the curved Davits bar. Okay, first, there is 4 structure to investigate this deflection in this experiment. There are semicircle, quarter circle, curved David, and an angle David structure. There are 2 digital deflection indicator set as 90 degree to each other to measure the horizontal and vertical deflection of the structure. Okay. The deflection indicator are very sensitive, so that our group so carefully to away from its happen any movement in this experiment. If any movement happen, it will affect the reading of the deflection indicator. Then it will affect the data table. Further, it will make some mistake for our group result. It will affect the result. Based on the result, the deflection for all structure, each horizontal and vertical, the deflection increase when the load are added. For the digital deflection indicator, our group has some difficult when to correct the position. It happened because the indicator is on a magnetic base. We are use vernier caliper to measure the diameter of each structure to calculate the inertia of the structure.
Next is the calculation for this experiment. In this experiment, we must calculate the theoretical value to compare with the experimental value that been shown from the result that I explained before. Here, this is the example of calculation for theoretical horizontal deflection value. The horizontal deflection can be found using this formula. Horizontal deflection are equal to 2 multiplied by P, which is the load, multiplied by R is radius power of 3, divided by E, which is the Young modulus, and multiplied with second moment of area that been calculated before. We just need to substitute all the info that already get into the formula to get the horizontal deflection value. The horizontal deflection value you will get in meter. So next is the example calculation for vertical deflection theoretical value. The vertical deflection can be found using this formula. Vertical deflection are equal to pi multiplied by P multiplied by radius power of 3 divided by 2 multiplied by Young modulus multiplied by the second moment of area. For this example, the P or the load is 0.98 Newton, while the Young modulus is same because the all specimen or structure has same value of Young modulus. We just need to substitute all the info that we get into the formula and calculated to get the vertical deflection value. So this is the result for the theoretical value that been calculated using using the two formula shown before. The table is quite same as the experimental value, but it has quite different value compared to experimental value that been measured and recorded through the experiment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Aiman bin Muhammad Sauti, and my metric number is DD180085. So today I will share to you about the discussion. So from the experiment, there are different values in horizontal and also vertical deflection. When we refer to the graph, we can conclude that semicircle deflection, quarter-circle deflection, curve David deflection and also Angus David deflection are all of the theoretical value is higher than the experimental value. As for that, the different value in those horizontal and also vertical may be due to the first is parallax error due to the incorrect reading taken in the experiment. The second one is inadequate preload met between the die gauge and also the load. The next one is workbench position, maybe not in flat position. This can be result that the specimen position is also unstable. The next one is vibration occur unexpectedly during the experiment. This will interrupt the reading taken during the experiment. So for the real life application, we can say that hook crane rings, chains and links are suitable and also be used in industry application through this method.
The last one is the conclusion. There are a few conclusions that can be made from this deflection of bars and David experiment. The first conclusion is the amount of load applied to the structure will affect the deflection value. It means the higher the load that applied to the structure or specimen, the higher the deflection for both directions. Second, we can conclude that semicircle structure have the lower strength when load is applied. This happen because semicircle structure recorded highest value in vertical and horizontal deflection value. The highest the deflection value means the weaker the strength of a structure. That means curve David is the strongest structure because it recorded and been calculated in the theoretical value. Curve David recorded least number of deflection for horizontal and vertical direction. As recommendation for this experiment is to get the accurate and precise result. It can be achieved by repeating the experiment for a few times and calculate the average value to get the best value and accurate deflection value.